Usual. So we're gonna talk about debugging today. So right now I'm not gonna be making a P5 sketch. I'm just gonna be showing some bugs. Okay, so I'm gonna make a little comment and say debugging examples. And so before we go into that, let's talk about what a bug is. The term computer bug comes from a computer programmer named Grace Hopper. If we look this up, we'll see an image probably of... I don't see it. Let's try Grace Hopper computer bug. Okay, there you go. So this image here is the first computer bug. And so this is from 1947. And so back then, computers were these like really gigantic machines where all of the switches were like physical like glass tubes that were switching electricity on and off to do the same thing that our silicon chips do now. And so when they were running programs, they had these things called logs. That's what the console is based on. So when we say console.log, that terminology also comes from this history of computer science. So we can see a log here. And in the log book, they would write down, I ran the program. This is what happened. This is what worked well. This is what didn't work. So this is a way to kind of test and, figure out how to get your computer to do what you want it to do. And in one case, they were running some tests and something wasn't working, and it turned out that there was a moth. So there was a literal physical bug that was stuck in the circuitry in one of the relays in the computer. And so they took the bug out and taped it into the logbook as an example of something to look for. And so that's where the term bug comes from. So when we say there's a bug in the program or we're debugging the program, that we're looking for reasons why the program doesn't work as it's intended to. So that's the first computer bug. And I'm sure you guys have seen examples of bugs as you've been writing some of your code. So I'll try to make a couple bugs here for some examples. So one bug that you might run into, imagine I do function setup and I say create canvas 400, 400. And then at some point by accident, I get rid of this extra curly bracket down here. One of the nice things about using P5 or a lot of different IDEs is there'll be some highlighting. So before we even try to run the program, we can see that there are some issues here because it's highlighted red. So if I run this, we're going to see this highlighted red. And then if we open up the console, we'll see this is called a syntax error. And so when we're debugging in JavaScript, we're going to get bugs that sometimes are hard to interpret. So that's why I want to talk about a few of the different types of bugs that you'll typically get. Sometimes another nice thing about using P5 is when we make mistakes that P5 is familiar with, sometimes it'll give us like little hints of what to look for. So when we're looking at a bug like this, we have to do a little bit of work to understand what it's telling us because it's not exactly clear immediately. So it says syntax error. So there's different types of errors. A syntax error is what happens when you there's something wrong with the syntax. So that's, our curly brackets, our parentheses, our commas, anything that's sort of part of the structure of the text that we're writing will give us a syntax error. And it says unexpected end of input. And so that's kind of a confusing thing because it doesn't tell us what's actually wrong with the program, which is that we're missing a curly bracket, but that's what it means. When we start a function, it's expecting us to have a ending curly bracket at the end of the function. And then it gives us a line number. So if we see where it says sketch.js, that's the file that we're writing in. So remember, we're using sketch.js to write our sketches. And then the first number here is the line. So we can match the line in the left side of the window to the line that it says here. The second number is actually the column. So if your bug, our bug is like right at the beginning of the column. So it starts on character 1. If it was like somewhere over here, it would be farther along in the column. So that gives us a lot of information for where to look and how to get started. So all I have to do is I close this bracket, and then we'll see that bug disappear. So that's kind of the basic process of finding a bug and getting rid of it. There's a few steps that I would kind of recommend when it comes to debugging. One of the things that we want to do is called framing the problem. So framing the problem is thinking through what is expected and what happened instead. So we can say, what did you expect? What happened instead? Okay. So framing the problem, when our program doesn't work, like when we hit the play button and we have a syntax error and nothing happens over here, sometimes our tendency is just to say, the computer's broken or the code doesn't work or, something's wrong. But computers just do what we ask them to do. So if it doesn't work the way we expect it to do, we have to look back at what our expectations were and then what happened instead. So in this case, what did I expect? I expected the program to run and to see the canvas. What happened instead? The program didn't run and I don't see a canvas. In that case, what's most likely is that there's some type of error, some type of fatal error. So fatal errors are these red errors, and they stop the program from running. So there's a few different types of bugs. So we have fatal errors. This means the program doesn't run or stops running, and red text appears in the console. So fatal errors are the easiest to deal with because it's very obvious that things aren't working. One thing that's a little bit of a disadvantage in JavaScript compared to classical programming languages like C or C++ or Java is there's not very many fatal errors. You can do a lot of things that are technically wrong, but your program is still going to try to run anyway. This is specific to JavaScript. You could argue about whether it's a good design or not, but the idea is to make it easier for people who don't know how to code to write programs without getting stuck on errors all the time. The problem is that you do stuff that doesn't work and you have no idea why. So fatal errors are sort of the easiest errors to deal with because they give us a lot of information about where to start. There are also errors of, well, there's a lot of different errors. We'll continue looking at them. So when we have a fatal error, that's easy to figure out. Sometimes, though, we don't have a fatal error. We just have a disconnect between what we want and what we see. So we can refer to that as sort of a disconnect between what we're expecting and what happens. So a good example of that would be, let's say I have an ellipse that I want to draw, and let's say I draw it at 1,000, 0, and 50 size. So when I run this program, I would expect to see, actually I'd expect to see more than what I'm seeing right now, which is nothing. Let's see. I'm going to save this and refresh it. So I'm getting a bug in my own concept or in my own lesson about bugs. Okay. Let's see. This should work, but just for the sake of it, let's try putting it in the draw function and see if that works. Oh, you know what? Actually, I'm not creating a background. That's the problem. So this is a conceptual error. This is actually a good conceptual example of a conceptual error is when you just forget to do something. Okay, so there we've got our canvas. So that is looking normally so far. So now let's say I try to draw an ellipse at 1,150 size. So I should see an ellipse on the canvas, but I don't. Does anybody know why I don't see the ellipse? It's bigger than the background? Yeah. Okay, so that's a very good, yeah, that's exactly right. So my canvas is only 400 pixels wide. I'm trying to draw an ellipse at 1,000 pixels. So that's much farther to the right than what I can actually see on my canvas. So if I adjust this, maybe I go back to 100, now we see the ellipse. So that's called a conceptual error. So conceptual error, there's no actual error that shows up in the console, but our program isn't running the way we want it to. Program doesn't run the way we expect. This is a much harder error to deal with because we have to go back through our code to try to understand why it didn't work the way it did. So we can look at another conceptual error, and then we'll talk about using the console for debugging. So I might have another conceptual error. Let's say I have a rectangle, and I'm going to draw this at 200, 200, and 100, 100. Okay, so I've got that rectangle. And let's say I want to base the size of the rectangle on a calculation. So I might say something like this. I want to make it, let's say I want to make it 10 times as big as the ellipse. And I know the ellipse is 50, and I'm going to say times, but let's say I do this. I say times 10. And now I don't get an error down here. There's no red error. P5 is telling me I'm doing something wrong, but we're going to ignore P5 for a second just for the sake of the instructions or for the demo. So there's no red error. There's no fatal error. My program is running fine. I can see the ellipse here, but I'm not seeing my rectangle. So in theory, I should be able to say 50 times 10, right? If I said 50 times 10 like that, now it works. Okay, but if I spell 10, it doesn't work. And we'll go more into data types in a future class, maybe next week actually. But for now, we just need to try to understand why this doesn't work. And you could imagine sometimes you're not even debugging your own code. Sometimes you get code from somebody else and you want to use it, but it doesn't quite work right. So then you have to debug somebody else's code. So this is where console.log is really useful. So I don't see any errors here. I can't see anything wrong with this. And so what I would start to do at this point is I would log out different parts of the program, different values, to try to understand if they are what I would expect. So I can say console.log and say 50 times 10. So I'm logging out what this value should be. And now I can look in the console and I can see right here, I get this value, not a number, NaN. So NaN is not an error. It doesn't break our program, but it doesn't work as a number. JavaScript doesn't understand it to be a number. So when we see that this value is not a number, that gives us a clue as to why we don't see the rectangle. We're trying to draw a rectangle with a height using a number that JavaScript does not recognize as a number. So that can give us a little bit of a sense of what we're missing. And so then we can go back and change that value to a number, and now JavaScript is happy. So that's the kind of difference between fatal errors and conceptual errors. And that's why framing the error is important. So you can figure out if you're dealing with a conceptual error or a fatal error, and then some steps that you might take to deal with one of those errors. So let's look at a couple more errors, and then we'll do the debugging exercise. Another error that you might see often is if you misspell a keyword. So let's say I'm trying to make the function draw, but I spell it with a capital D. and I'll put some of this code into my draw function. Okay, so if I run this, actually we don't get a fatal error here. Oh, because P5 is kind of interrupting to say, it looks like you meant to write draw instead of draw. So this is actually a conceptual error. You won't get an error here, but P5, when it notices things like that, it will say, you know, this doesn't look right. Let's see if it does the same thing if I spell draw without a W. Let's see if they notice that. So they don't actually notice that one. So there's some limitations to what P5 will be able to tell you. Okay, so then we have draw. Another thing you might do is misspell a keyword, like maybe I left out the C in function. If I do that, that'll give me a fatal error. And that's another syntax error. So this one is also kind of confusing. It says unexpected identifier draw. So that makes you think that maybe the error has to do with the draw function. But really the reason that this is unexpected is because this keyword is not a real word, or is not a real keyword. So it's confused about what draw means when it comes after this non-existent thing. So again, the sketch tells us, the error tells us it's on line 10, and here the column says 9. So you can see, you know, this is just 1, 2, 3, 4, 5, 6, 7, 8, 9. So the error starts over here. Okay, so let's return this to function draw. Another error that you might come up with is if you're using a variable that doesn't exist. We haven't really talked about variables yet, but we will next week. But let's imagine I was trying to draw another rectangle at x and y and 200 and 200. So that's a fatal error. The program won't run. So if I try to run this, it starts to run and then it stops and says reference error, x is not defined. So that's another common error, is a reference error. This is when a variable that you're trying to use doesn't exist. We'll talk a little bit more, as I mentioned, about variables next week, and so we'll go over more examples. But that's a common error that you see. Sometimes that's also a spelling error. Like imagine I had a variable that did exist. Let's say I had a variable x equals 10, and then I was using x, but let's say I capitalized x. I would get the same error, x is not defined, even though I am technically defining x here. Since one is lowercase and the other is capitalized, it doesn't recognize that as the same value or the same variable. And so I get the same reference error. So reference error happens when you either misspell a variable or you use a variable that doesn't exist. So the syntax error and the reference error are probably the most common errors you're going to run into. Let me see if there's any others we should talk about. Let's see. We're probably not going to run into any range errors anytime soon. A lot of different syntax errors. We're probably not going to hit any type errors. Yeah, so I think those are the main errors we'll probably run into at the beginning of class. Sometimes in the console you'll see warnings. Those are like little yellow things. If just as an example, you might see something that looks like this. So this isn't a real warning, but I'm just going to use the console to make a warning. So if you see a yellow warning like that, that doesn't mean that your program is broken, but it means that you're doing something that the browser probably doesn't want you to do, or something that might be deprecated in the language or something like that. For now, I would just say ignore those. So I'm really just bringing this up just to say if you see red errors, those are things that we need to fix. If you see yellow warnings, you can pretty much just ignore those, at least for this part of the class. Okay. So let's look at the debugging project for just a second, and then we'll work on that. So for the JavaScript debugging project, there's a sketch here that has a bunch of bugs in it, and I basically just want you to go through and fix those bugs. So when you try to run the sketch, you're going to see this syntax error, and once you fix that syntax error, you're going to see another error. So to start doing this, you can just click on this link right here, debugging exercise sketch, and you can make a copy. So you don't want to work on my copy because it's not going to save because you're not logged in as me. The first thing that you need to do is go to File and Duplicate. Duplicate a copy. Once you do that, you'll see your name here instead of mine, and that way you can save your changes. If you don't do that, anything that you change is not going to be saved. You won't be able to submit it. When you're done with the exercise, you should see an image that basically looks like this. If it's not 100% like this, then that's fine, but it should mostly look like that. So there are a number of fatal errors, like the ones that we looked at. There are also some conceptual errors. So, this is just an exercise to kind of go through looking at different errors and practice looking for how to fix them. Remember that when you see an error, you're going to want to have the console open. And if you open this error by clicking on this little arrow, it's going to tell you what line to look at. So that's the first thing you want to do is go look at that line. Sometimes errors are caused by code that is not on the line where the error appears, but that's where you're going to want to start. All right, so I'll stop here.